Hello and welcome you all. Dear students, this is part 2 for the quick revision of basic electrical engineering, which is the subject for first year engineering students. In part 1, I have completed the revision for unit number 3 and 4. Now the part 2 will give you exact idea about unit number 5 and unit number 6. Let us start with unit number 5, which is DC circuits. Actually, in this unit, from this unit, you can expect more numericals compared to the theory part. So without wasting the time, let us start the session. Before I forget, I will give you some important clues to solve the numericals. Don't skip the numericals. There are certain tricks so you can easily attempt any numerical. So first part is find equivalent resistance between BC in the following circuit. This is the given diagram. Actually, many students are getting confused when to consider the resistance in series, when to consider in parallel, and so on. This is the given network. It is asked to calculate the equivalent resistance between terminals BC. The points are marked in the question. This is BC. When the points are given in the question, do not start simplifying the network from those points. So BC points, 4 ohm resistor, I will keep it as it is till the end. This is first clue. Now, think like this. Can you take any series or parallel combination? No, make the thing simple. Series combination means the two resistors must be connected one after other. For example, if I am talking about this 9 ohm and 12 ohm, they are connected one after other. So this diagram contains 9 ohm resistance and this is 12 ohm resistance. They are connected one after other. Actually, they are in straight line like this. This is say 12 ohm and this is 9 ohm. To make the diagram simple, I have bent the wire like this. So these two resistors are in series. When the resistors are in series, perform the addition. So you can, in the exam, you can well write this as 9 and 12 ohms are in series. So combined will be 9 plus 12, that will be 21 ohm. Now another common thing. Whenever you will take any series or parallel combination, for example, in this case I have considered these two in series combination. So remove any one of the resistors. For example, I will remove 9 ohm, keep another as it is. You can remove any resistance, and for the remaining, write down the resultant value which you got after calculation. So this value I will write it as 21 ohm. Another very important part. 99% numericals, whatever we are solving, is a ladder type numerical. Forget about the name. So only first combination is important. If first combination is series, next will be in parallel, third will be in series, and so on. As I mentioned, it is happening in 99% cases. First combination I took in series. So now this 20 ohm and this 7 ohm, they will be in parallel. One more important thing for another numericals, remember it like this. If I have two resistors like this is R1 and second resistor say R2. How to check whether they are in parallel or not? Suppose I will make the connection like this. I want to check whether they are in series or parallel. Think like this. This R1 is having one terminal A, second terminal B. R2 is having one terminal C, second terminal B. If first terminals, A and C, are directly connected, there is nothing in between, as well as the ending terminals A, B and D are also directly connected, nothing in between them, then these two resistors are said to be in parallel. Apart from this, what I said, the first combination was in series. That's what we solved and we got the value 20 ohm. Now this 20 ohm and 7, I will be taking it in parallel. So in the exam you will write it like this, taking 20 ohm and 7 ohm in parallel. So you can write it like this, 21 ohm in parallel with 7 ohm. I hope you are aware how to solve this parallel combination. Very simple. In the numerator, take multiplication, 21 into 7. Into denominator, take addition, that is 21 plus 7. You can well simplify it on the calculator. So this answer will be 5.25. Again, to avoid the confusion, remember the simple tricks. What I did, I have taken these two resistors in parallel. Remove any one of the resistors. Keep another as it is. So for example, I will remove this 20 ohm. Remove all the connections related to 20 ohm. Remaining is 7 ohm. For the remaining, write down the resultant value, that is 5.25. So I will write it here 5.25. Now to get this value 5.25, I took parallel combination. Now next is third combination, take it in series. So this 5.25 will be in series with 3 ohms. So it will be 5.25 plus 3, it becomes 8.25. Again same logic. You have got 8.25. After taking this in series combination, remove any one of the resistors. So let us say I will remove 3 ohm resistor, join it by a line, and then instead of this I will write the resultant value 8.25. Now this I got 8.25 I got by taking a series combination. So last part will be, since it is series, last I will take it in parallel. So resultant answer will be, you can write it like this, RBC, because it is asked to calculate resistance between B and C. So it is 8.25 in parallel with 4 ohm. As I mentioned, at the end consider the resistance of branch which is given in the question, that is BC. So if you simplify it on the calculator, 8.25 into 4 divided by 8.25 plus 4, so answer will be 2.69 ohm. This is the resultant value. You can well expect any numerical related to this part, just it will be mentioned calculate equivalent resistance between these 2 points. You will have to consider only series and parallel combination. The next important part from this unit is delta to star and star to delta conversion. First of all, try to understand what's a delta network. Delta network is like a triangle. Do remember these notations. This terminal is 1, 2, 3. Resistance between 1 and 2 is R12, between 2 and 3 is R23, between 3 and 1 is R31. Strictly follow this sequence so that there won't be any confusion. So the sequence is like this, 1, 2, 3. Now this is known as a delta network. This is called a star network. It is like a Y network. Now again the sequence is same, 1, 2, 3. This is a common point, yes, which is denoted by S. This resistance is R1, R2 and R3. Now remember the simple tricks. If you want to convert delta network into star network, I want to convert this delta into star network. So draw the star network inside given delta network as it is. So I will draw this star network like this. This is the star network. Conventions, strictly follow these conventions which I have shown in the diagram. Now recall the rule, make the thing simple. Any resistance in star network is equals to product of adjacent resistance in delta network divided by addition of all resistances delta. How to do it? What I did, I want to convert this delta into star network. Inside the delta itself, I have drawn this star network as it is. Now, for conversion, I will make use of this formula. R1 is equals to, I'm talking about this formula. Look at this diagram. For R1, adjacent resistance are these two, I mean R31 and R12. So equation will be R12 into R31 divided by addition of all. Addition of all means R12 plus R23 plus R31. So this is the value of R1. Same way, if you want to write value of, if you want to calculate R2, for R2 adjacents are these two, R12 and R23. So I will write it like this, R12 into R23 divided by same thing, R12 plus R23 plus R31. Now the third resistance R3. Look at the diagram for R3. Adjacent resistance are R31 and R23. So I will write it like this, R23 into R31 divided by addition of all, R12 plus R23 plus R31. So this is the way how you can convert the delta network into star network. After conversion, remove this outside delta network. For example, I will draw this outside delta network over here so that for the latter we can use this network. So this is the outside delta network. This resistance is R31, this resistance is R12 and this resistance is R23. What I am talking about, after converting the delta network into star network, remove the outside delta network. So remove this network. This is the resultant diagram in which we have converted delta network into star network. Strictly follow this rule. It is the simplest way to convert delta into star network. You can use this technique to simplify any network. To reduce down the calculations, you can use this method. Now consider the reverse case. If you want to convert star into delta network, this is the given star network, inside network, which I have drawn with blue colored pen. So it is R1, R2, R3. R1, R2, R3 is the given star network. I have to convert it into delta. So outside this star, draw the delta network, which I have already drawn. Make use of this formula. Any resistance in delta is equals to total resistance RT of the star network. I have written the formula of total resistance. It's again simple. RT is, remember the sequence, R1, R2, R3. So it is R1 into R2 plus R2 into R3 plus R3 into R1. This is total resistance RT of the star divided by opposite resistance of star. Now, I have to convert this star into delta. So think like this. First, I have to calculate value of R12. So I will write the calculation over here. If I want to calculate value of R12, look at the diagram. For R12, I am talking about this resistor. Opposite resistance in the star is this one. Opposite means perpendicular. Think like this. Perpendicular resistance is R3. So it will be RT, where RT is this entire thing. This RT divided by R3. Second value. Suppose R23. I want to calculate this value. R23. For R23, look at the star network, star resistance, which is opposite. Opposite means perpendicular. So if you extend this line, this will be the perpendicular. So it is RT upon R1. Next, suppose I want to calculate R31. For R31, which is perpendicular or opposite resistance, it is R2. So it is RT upon R2. And of course, do remember this formula to calculate the total resistance. So very simplified technique. You can using these two formula, you can convert delta to star as well as star to delta network. The next part is KVL, that is Kirchhoff's voltage law. I have written the statement in a closed mesh or loop. I will explain what's the mesh or loop. Algebraic summation of voltage drop across each element is 0. Now, students are usually finding it difficult while attempting the question of KVL. But once the things are clear, once basic concepts are clear, you will be in a position to solve any numerical. Listen this problem carefully. Suppose it is asked to calculate, apply KVL for this given network and calculate the loop currents. First of all, what's the loop? It is called as a closed path. For example, if I will give some names randomly, say A, B, C, D, E, F, then A, B, E, F, A is one loop. Loop is what? You are starting from some point and you are coming back to the same point. So A, B, E, F, A is one loop. This B, C, D, E, B is another loop. So there are two basic loops. If you want, you can consider extra loops, but as far as our syllabus is concerned, these basic loops are more than sufficient. Next step is, once you will decide how many loops are there, how many basic loops are there, inside every loop, mark the loop currents, strictly follow this direction, like this. As I said, it's not technical rule, but if you follow these directions, calculations will be pretty simple. In any numerical, irrespective of polarity or whatever given things, strictly assume these directions for the loop current. Loop current is the current which is flowing through entire loop. For example, I1 is a loop current flowing through A, B, E, F, A, entire loop. Similarly, I2 is a loop current flowing through B, C, D, E, B. That means for the entire loop 2. After this, do remember the basic things. In case of any resistor, if I will consider one resistor, say R, and I will show the current flowing through like this. How to mark the polarities? Very simple trick. Current always flows from positive to negative. So at this LHS I will mark positive, at RHS I will mark negative. I have already marked the loop currents across each resistor. Now I have to mark the polarities. How to mark it? See, for 2 ohms, now once you will mark the loop currents, strictly follow the direction of loop currents. For loop current is flowing like this. So I will mark here plus, minus. For this 4 ohm, this current I1 flows like this. So I will mark plus, minus. There is no resistance. Now, this is a voltage source. In case of voltage source, the voltage source is shown like this. The longer terminal always indicates positive, shorter terminal always indicates negative. So I will directly mark here plus minus without thinking of current. Come back to loop 2. For loop 2, for 3 ohm, the current I2 moves like this current is like this. So I will mark the polarity like this, plus minus. For 5 ohm, the current I2 flows like this in a downward direction, so plus minus. Again, this is a voltage source of 50 volt. This shorter terminal indicates negative, longer terminal indicates positive. So by using these simple techniques, I have marked the polarities across each element. After completion of this, the remaining part is pretty simple. You have to just make use of only two simple formulae. What are those formulae? If you are moving from positive to negative, consider it as negative. Give a minus sign. Second rule, if you are moving from negative to positive, consider it as positive. That means give that voltage drop as a plus sign. We'll discuss how to apply these rules. Now suppose I want to write KVL for loop 1. So there are two loops I'm considering. First, loop 1. For loop, you can start from any point, but the thing is that you need to come back to the same point. You can start from any point. For example, since this loop is A, B, E, F, A, I will start from point F. From any point you can start, but strictly follow the loop directions. That means if I assume this as a direction, you have to move in the same direction only. So if you start from point F, you will have to move from F to A because loop current is like this. You cannot move from F to E. You will have to go from F to A. Now from F to A, I am moving from minus to plus. So minus to plus is plus sign. So first part I will write it as 100 ohm. This is first value. Second, this is resistance. This was the voltage, so I directly wrote the value. This is the resistance. Look at the signs, plus minus. I will have to move like this only. Plus minus is minus sign, give minus sign. For resistor, write the equation like this. See, we know that voltage drop is given as I into R, that is current into resistance. Then since this is resistance, current flowing through this is I1. I have already decided its sign is minus, so minus 2, value of resistance is R into current I1. For resistance, write the value of resistance into current flowing through this. Now come back to this. Plus minus is minus, plus to minus is minus, so I will write minus, value of resistance 4. Now, very important part. Through 4 ohm, both the currents are flowing, I1 as well as I2, because I1 is flowing in downward direction, I2 is flowing in upward direction. In such case, first write this minus sign according to this rule, write the value of resistance. All these things are as it is like the previous case, but inside the bracket write I1 minus I2. See, if you are following these directions, whatever I explained you like this, always and always for common resistance there will be minus sign in between. Question arises whether to consider I1 minus I2 or I2 minus I1. Make the thing simple. If you are using loop 1, write it as I1 minus I2. When you will write equations for loop 2, it will be I2 minus I1. Presently, I am talking about loop 1, so it is I1 minus I2. Now we have come back to up to this point E. There is nothing in this branch, so I will not write anything. And again, I have reached up to point F from where I started. Final equation equated to 0. Just simplify these equations. How to simplify it? I1 and I2 should be at one side, constant should be at other side. Give some equation number to that equation, that is equation 1. Same way, we will try to write the KVL for loop 2. I already marked the polarities. Again, same logic, start from any point, but you need to come back to the same point. So loop 2 is B, C, D, E, B. Let us say I will start from point B. Again the same rule, you will have to follow the direction of current like this. That means I will have to go from B to C, not from B to E. So let us consider first part B to C. Plus to minus is minus sign, so I will write minus, value of resistance is 3, current through 3 ohm is I2, so it is minus 3 I2. Then again come back to this plus to minus is minus sign, resistance is 5, value of current is I2, through 5 ohm I2 is flowing. Come back to this branch, It is minus to plus. Minus to plus is plus sign. Value is 50. So I will write plus 50. In case of voltage, you will have to write direct value. In case of resistance, value of resistance into current, like this. Now come back to this. Now I have to write equation for 4 ohm. See, I2 is flowing like this. So below there will be plus sign. Above there will be minus sign for loop 2. Since the current I2 through loop 2 flows like this, so I will write plus minus. Since I am moving from plus to minus, I will write minus 4. Now, through this 4 ohm, both the currents I1 and I2 are flowing. Just now I explained you the rule. Since you are in loop 2, write it as I2 minus I1. Equate it to 0. Again, simplify this equation. I1 and I2 at one side, constants at another side. Give some equation number, say 2. Now, on the calculator, you will have to just solve these two equations and you will get the answers for currents I1 and I2. Dear students, this is the simplest technique to solve any numerical related to KVL. The numerical can be anything, values can be changed, but procedure remains same. You just have to follow these two rules. This is about the KVL. Now, related to this, again one more theorem is there in your syllabus, that is superposition theorem. So you need to prepare the statement of superposition theorem, as well as there is Thevenin's theorem in your syllabus. So you need to prepare the statements of both the theorems, Thevenin's as well as superposition. One more thing, I have already created video on all the topics of this unit. For example, KVL, superposition, Thevenin's. If you want additional numericals for practice, do watch that video. I have already given statements and explanation. Question can be like this: state and explain superposition theorem, or state and explain Thevenin's theorem. I have already given statement and explanation. Please do watch that video. I will provide the link in the description box. Okay. Suppose it is asked to use the superposition theorem. This value is 4 ohm, if I am not wrong. Yeah, it's 4 ohm. If it is asked, use the superposition theorem and calculate current flowing through 4 ohm. Anything can be asked. Then, do remember the basic things. How many sources are there in the given diagram? There are two sources, 100 volt and 50 volt. Both are voltage sources. At a time, consider only one source. For example, I will consider case 1. So first I will consider only one source. Let us say I will consider 100 volt source. So 100 volt will be as it is in the diagram. This is 50 volt source. If remaining source, do remember this simple rule. If remaining source, remaining means what? Remaining means you have considered one source, whatever remaining sources in the diagram. If it is a voltage source, use short circuit. If remaining source is current source, then use open circuit. These are only two simple rules. So if you're considering 100 volt, that means I'm not considering 50 volt. So for 50 volt, make a short circuit like this. Short circuit means join it by a simple wire. Now use any method. You can well use KVL and calculate the current passing through 4 ohm. You will get the answer of that current. Let us say that current is denoted by I1. Now consider case 2. In case 2, what I did in first case, I have considered 100 volt. In case 2, now consider the remaining voltage source, that was 50 volt. So since if I am considering 50 volt, remaining is now 100 volt. Since it is a voltage source, use this rule, make a short circuit. So I will make a short circuit, that means join it by a straight wire. Again use KVL and calculate the current passing through 4 ohm. Let us say that answer is I2. Final answer will be I1 plus I2. This is the way how you can use the superposition theorem to solve any numerical. You can use this trick to solve any numericals as far as this superposition theorem is concerned. Now, one more theorem is there in this chapter, that is Thevenin's theorem. Again, you need to prepare the statement and explanation of Thevenin's theorem. I am talking about how to solve the numericals. If it is asked to calculate the current passing through 5 ohm resistance, let us say 5 ohm because it is connected at the output side, using Thevenin's theorem, then how to do it? I will explain you the steps. First step is, since it is asked to calculate current passing through CD, branch CD, that is through 5 ohm, first step is open circuit the resistor. Means 5, it is asked to calculate the current passing through 5 ohm. So first step is open circuit this. So open circuit means directly remove that resistance and mark it like this. This is known as open circuit. Second step, calculate VTH. VTH is what? Thevenin's equivalent voltage. So wherever you have made open circuit, from this point, I will measure voltage drop between these 2 points using any technique. Again, you can use KVL for this branch as well as this branch. Use KVL, calculate the current, and then you will get the voltage, that is VTH. And third step is calculate RTH. RTH is known as Thevenin's equivalent resistance. How to do it? Again, make use of the same rule. From this point, you have measured VTH. Now, from this point, look at the network and you will have to calculate RTH. How to do it? While calculating RTH, if in the circuit voltage sources are there, short circuit it. If current sources are there, open circuit it. So there are two voltage sources. One is 100 volt, another is 50 volt. What's the rule? To calculate RTH, RTH is Thevenin's equivalent resistance. Wherever voltage sources are there, remove it and simply short circuit it. Join it by the wire. Similarly, remove this, join it by the wire. This is the resultant circuit. If you want to calculate RTH in this case, see, make the thing simple. If you are calculating RTH, then do remember the simple rule. From this end, you are looking towards the network. So from the remaining end, opposite end, start doing calculations. Now these 2 ohm and 4 ohm are in separate wires. They are in different wires. Or think like this. B is one terminal of 2 ohm, A is another terminal of 2 ohm, E is one terminal of 4 ohm. This one terminal is directly connected. This is a simple wire. That means this E and A is again directly connected because nothing is there. So, or make the things like this. If the 2 ohm and 4 ohm, they are in separate wires. These are two different wires. They are in parallel. If they would have been in same wire, they would have been in series. Since 2 ohm and 4 ohm are in two separate wires, they are in parallel. So I will write it like this: 2 parallel 4. After doing this calculation, you will get one value. Remaining resistance is 3. Since I have taken this in parallel, remaining take it in series, plus 2 will give you the value of RTH. Final step is, after calculating VTH and RTH, last step is draw the resultant diagram like this. Show one voltage source whose value is VTH, which you will be calculating in this step 2. In series with this, show one resistance whose value is RTH. RTH, just now I have shown you how to calculate it. This is known as the Thevenin's equivalent diagram for the given network. Now, last step is, from this, there was a 5 ohm resistance which I removed earlier. So, connect the resistance as it is. This is known as the Thevenin's equivalent diagram. So this was about the unit number 5, that is DC circuit. Now let us talk about the last unit. The last unit is unit number 6, work, power and energy. First we will discuss the definition of one term, that is RTC, resistance temperature coefficient. The factor by which resistance of material changes with temperature is RTC. Now, do remember the typical graph. The question can be like this: define RTC and explain it with respect to the graph. So, this is the graph of resistance versus temperature of a certain metal. Now, on x-axis I am plotting temperature. Here at this point, at the origin, I have T is equals to 0. Whatever value of there at T is equals to 0, that resistance is denoted by R0. I have considered two time instants, T1 and T2. At T1, resistance is R1. At T2, resistance is R2. Very simple. Now there are some coefficients. Let us say alpha 1. Alpha 1 is the coefficient of resistance at temperature T1. This is the formula to calculate alpha 1 related to R2 and R1. I have already marked the values of R2 and R1. These are resistance at times T2 and T1 respectively. Similarly, alpha 0. Alpha 0 is the value of coefficient at 0 at origin or at T is equals to 0. This is the formula to calculate alpha 0. How to remember this formula? If you know this formula, just think like this. This is alpha 1 is R2 minus R1 divided by T2 minus T1 upon R1. I want now alpha 0. So instead of 1, I have 0. So instead of R1, it becomes R0. Instead of T1, it becomes 0. Instead of this R1, it becomes R0. Now the next is the formula between alpha 2 and alpha 1. Alpha 2 is coefficient at T2, alpha 1 is coefficient at T1. This is the relationship between alpha 2 and alpha 1. All these formulas are required while solving the numericals. And last, if you want to calculate any value of alpha, say alpha 2 or alpha 1, whatever, related to alpha 0, then you need to make use of this formula if you want to calculate it related to alpha 0. Now the remaining part is the definition of insulation resistance. It is the resistance that provides opposition to the flow of current is called as insulation resistance. Very simple normal definition of resistance which provides opposition to the flow of current. The value of resistance is given by the formula rho L upon A. Rho is called as resistivity of the material. Resistivity is the property, in simplified language I am talking about, is the property by which it causes the opposition. So rho is resistivity, L is the length of wire, A is the cross sectional area. There is one more important term, that is Ri, which is the formula for insulation resistance. Ri represents insulation resistance. It is applicable in case of a coaxial cable. In case of coaxial cable, there are two cylinders. One is inner cylinder, which is usually made from the copper, and outside this one more cylindrical structure is there that is made as acting as a protecting layer, which is made from the plastic. So there are two cylinders, one placed inside the other. So if R1 is the inner resistance means or think like this, inner radius, I have made a mistake, it is inner radius of the cylinder, and R2 is outer radius of the cylinder. So it is inner radius, that means radius of copper conductor, and outer radius means radius of the plastic material. So these are the values, and this equation Ri gives you this is the formula to calculate the insulation resistance in terms of insulation resistivity. Rho is the resistivity, and meaning of R2 and R1 I have just now explained. Next part is you can well expect the numericals related to calculation of energy, power, efficiency, and water billing, and so on. So these are only simple formula. If you know this formula, you can well attempt any numerical. First is output energy, E0 is given as mgh. M is the mass, G is the gravitational constant, H is the height height of say some water tank to which some motor is connected. Now do remember the formula relationship between energy and power. Power is energy upon time. Another important thing is, if in the question it is asked to calculate energy, calculate power, and calculate monthly billing, if this word is used, then you might have come across this notation, that is unit. Unit is related to the billing process, monthly electricity bill. How to do this calculation? First calculate power, whatever value is there, convert it in terms of kilowatt. If you are getting answer in watts, convert it in kilowatts by multiplying it by 10 raised to minus 3. Then the unit will be kilowatt hour. If it is in seconds, convert it into hour. I hope you are aware how to convert time from seconds to hour, and so on. And whatever value is there, that is 1 kilowatt is corresponding to 1 unit. Accordingly, you can well do the calculation of the billing if it is asked. But basic calculation is this, only these two simple formula are sufficient, and we need one more extra formula, that is the calculation of efficiency. Normal formula, it's output energy, ratio of output energy to the input energy. The remaining part from this unit is batteries. Dear students, these are the theoretical points, so don't skip that point, as well as there are two types of batteries, lead acid battery, the lithium battery, as well as do the comparison between these two batteries. So that's it for the revision section. Dear students, I have tried my level best to provide you some tricks, some things, how to correlate the things and how to remember the important formulae. So that's it for the today's section. All the best for your exam. Thank you. Thanks a lot.